Hello everyone. In this lecture we will talk about errors and corrections. This topic is very important in surveying because in most of the cases we have some experiments and some practical projects. In those experiments and practical projects we will collect data, and this data should be corrected because in some cases it is not 100% correct. We may have some mistakes, we may have some errors, and we have to find the sources of errors and mistakes, then we can take corrections. The outline of the lecture is like this. We will talk about errors and corrections, and then the sources of errors, and after that we will talk about accuracy and precision. That is very important, and they are two important terms in errors and corrections. And we have some types of errors, and then we will talk about systematic errors in taping and corrections. First of all, what is error? Error is generally defined as the deviation of the measured value from the exact value of a quantity. For example, if we have a line, the line may be for 100 meters. When you measure this 100 meter line, you may measure 99.5. It means the measured value is different if compared to the exact value or the true value. The study of errors is important in surveying as it helps the surveyor to understand the sources and exercise the necessary care and apply correction to minimize their effect so that an acceptable accuracy is achieved. Why studying errors is important, as I told you, because when the surveyor knows the sources of errors, so he or she can apply corrections. He or she can exercise the data and also find the sources of the errors. Then the errors can be decreased and minimized. We have some sources of errors. The three main sources of errors are personal errors, instrumental errors, and natural errors. What are the personal errors? The personal errors are the errors that occur due to the lack of the perfection of the surveyor's sense of sight, touch, or hearing. For example, if you cannot see perfectly or if you cannot hear perfectly. So in this case, you may read, for example, 65 as 56. So the error is very gross, and in some cases it is because of the fatigue or careless of the surveyor. So this type of surveying is called personal errors, and this type of errors can be minimized by taking more care and vigilance by the part of the surveyor. So personal errors are the errors that are related to the surveyor. In some cases they are very gross and the error is big, so the only way to correct it, this type of error, is to repeat the exercise or repeat the experiment. Another type of surveying is called instrumental errors. This type of error is due to the imperfection of the instruments. For example, when you use a level instrument or a total station, the level instrument may not be perfect. So in this case, while you are reading something, there will be a mistake in that reading. So in most of the cases, this can be minimized by the careful handling and maintenance and adjustment of or calibration of the instruments. Or in some cases, if you know the source of the error within the instrument, you can take corrections. So you have to be very careful about the instruments. You have to handle the instruments very carefully, and also you have to conduct maintenance procedures in every 2 or 3 months, so as to be sure about the perfection of the instrument. Another type of error is called natural errors. This type of error is related to the humidity and temperature of the environment, or the pressure or magnetic variation. For example, if you have a wind and you use a long range pole or a long staff, so in most of the cases the staff will move due to the effect of wind. So This type of error can be minimizing by applying the correction or carrying out the experiment in another time that is suitable for this type of experiment. So generally we have those three types of errors: personal errors, instrumental errors, and natural errors. We have two important terms in errors and corrections. The terms are accuracy and precision. Now we will differentiate between these two terms. Why measurements are not equal to the true value? Because all the measurements include errors, and errors may be a technical error or instrumental error, or it may be a man mistake, or it may be a personal mistake. So it means the real value is deviating from the measured value with a ratio. So this kind of deviation is called the lack of accuracy. So means accuracy is how you are close to the real value. So for example, in this picture, if the real value is the center of the circle, so now you should measure exactly the data that is located in the center of the circle. When you are deviating from this center, it means your accuracy is low. As you see in this picture, we have many data. Okay, all the data has been deviated from the center of the circles. So now, for example, the number of the data may be 8 or 7 pointers. All the 7 pointers has deviated from the center. So it means in this case we don't have a good accuracy. So accuracy in this case is low. But precision is the agreement of all measurements for multiple trials. For example, in this case, in the first case, I'm talking about this first case. In this case, all the data, all the measured data are very close to each other. As you see, all the pointers are very close to each other. It means the precision of the data is high. So it means we have low accuracy, but we have high precision. So this is the first case. In the second case, as you see, the data is exactly on the center of the circle, and also all the pointers are very close to each other. As you see, they are in the center, and also the pointers are very close to each other. In this case, we have a high precision because the points are very close to each other and they are exactly on the center. So it means we have a high accuracy. So in this case, we have a high precision and high accuracy. But in the third case, the pointers have been deviated from the center and they are far away from each other. Okay, as you see, one point is here, one point is here, one point is here. So it means the accuracy is low because they are very far away from the center, and likewise the precision is low because the pointers among themselves are not close to each other. So this is called accuracy and precision. In the fourth case, okay, we have some data, some pointers, and the pointers surrounded the center of the circle. As you see, they are close to the center, but the pointers are far away from each other. So in this case, precision is low, but accuracy is high. So this is the main difference between accuracy and precision. We have some derivations for the formulas for accuracy and precision. Really, this is only for understanding. Accuracy is the estimated value minus the real value. But for the precision, we can find precision by the standard deviation formula. This formula is called the standard deviation formula. So in mathematics, you may have this formula. So what is the meaning of standard deviation? Standard deviation means the spread of the data around the mean. So in this case, SD is the standard deviation, X is the data, the number of data, for example, data number 1, data number 2, data number 3. For example, in data number 1, you may read 1.5 meter. So you should write 1.5 meter here. So what is X bar? X bar means the mean or the average of the data. For example, if you have 7 readings, so you have to take the average, and the average will be x bar. N is the number of the data. For example, if you have 7 readings, so you have to write 7 here. So this is the formula of the standard deviation. We will use the same formula for finding the precision. So as you see, we have this formula. The only change in this formula is we should write n minus 1 under the formula. In this figure, standard deviation or precision will be clear. As you see, if you have, for example, 7 readings or 6 readings, this may be the first reading, this may be the second, the third, and also we have those readings likewise. So the average or the mean of those readings is here. It is exactly on the center. And then we have a distance between the mean and this data. We have another distance between the mean and this data. So it means there's a specific distance between the mean or the average with the other readings. So this distance, okay, how far the data is from the mean of the data is called standard deviation, or is called the precision. This is only for the clarification. In this example, we have 5 different readings for the length of a line. So the line AB has a true length of 10.548 meters. So we used a tape for measuring this line, and the measurements have been different. We have 5 different readings, so we have to find the accuracy and precision. So the length or the average length of our readings, because we have 5 different readings, the mean of those readings is summation of all the readings divided by the number of the readings. So now 10.550 plus 10.552 and so on, like this, divided by n. N is 5, so the mean length or the average length will be 10.549 meters. Okay, so now based on the standard deviation formula, we will find the precision. So for finding the precision, the summation of L mean, L means the average length, so we have found the average length, minus Li, Li means L1, L2, L3, L4 and L5. So with the power of 2, n minus 1, n is equal to the number of the readings, that is 5. So based on this equation, we can find the standard deviation, that is 0.002 meters. So it means our precision is like this. So how can you find the accuracy? Accuracy is the estimation minus the real value. So here is the estimation, the measured value, and we have the real value that's given in the example. So we have found the accuracy, that is 0.001 meter. So based on those two formulas, we have found the precision and the accuracy. Now we can say that the length of the line AB is equal to 10.549, the mean, plus minus 0.002. Okay, why? Because the precision of our measurement is 0.002. It means this number may have an error with 0.002. It may be higher than this or maybe lower than this with this number. So this is a very simple calculation to find the accuracy and precision of different experiments. We have some types of errors. Now we know the sources of errors, that may be personal, instrumental and natural errors, but we have some types of errors. Okay, the first type of errors is called random errors. These are the types of errors that remain after elimination of mistakes and systematic errors. So they occur because of neither the surveyor nor his or her instruments are perfect. For example, if you have an instrument that's not perfect, and also if you don't know how to use the instrument, so the errors cannot be minimized, the errors cannot be decreased. So they are random in their nature and are thought to have normal probability distribution. The effect can be greatly decreased by exercising care and vigilance by the part of the surveyors and by using high precision instruments. So those type of errors cannot be minimized by calculation or by taking mathematical corrections, because if you, for example, read something in a wrong way, so you cannot take corrections. Systematic errors, this type of error can be minimized by taking mathematical corrections, because in some cases you may have one small mistake, and this mistake can cause a systematic error in your instrument. For example, a group of data may deviate from the original value by a percentage. So you can correct the data by taking a mathematical correction. Okay, we have another type of error that is called mistake or gross. These are actually not the error, because they usually are so gross, they are very big in magnitude and compared to the other two types. So in this case we should neglect this error. Okay, these are rather the blunder made by the surveyor or his equipment, and can occur at any stage of the survey during the reading, recording, computing and plotting. As I told you, we may have some mistakes. In some cases you may read, for example, 75 instead of reading 57. So this type of error cannot be corrected. In this case we have to neglect this data. So this figure is showing the difference between the three types of errors. As you see, if we have these two lines, and the two lines are the true values or the exact values that we want to measure. So as you see, the data, the red pointers are very far away from the two lines. So it means the error is random, and we have a mistake in using the instrument, or we as a surveyor are not perfect in using those instruments. So this is called a random error. Systematic errors is like this. As you see, all the data are very close to the two lines, but we have a group of data that has been deviated from the true value. So most probably we have one single mistake that causes this type of error. So we can remove this gap by taking a mathematical correction. And also in this case, in the gross errors, as you see, we have this data, and also the data is relatively close to the two lines, but we have one single reading that is very far away from all the other readings. In this case, we know that a mistake has happened in this data, so we have to neglect this, because this is a gross error. It is just like reading 57 instead of reading 75. Okay, so this cannot be corrected, so you should neglect it or repeat the experiment. So we have those three types of errors. Systematic errors in taping and corrections. You know, while using tapes for measuring distances, we may have some types of errors. The first type of error is the standard length of the tape. In some cases, the tape may be short or it may be long. So in this type of error, we have some corrections that we can conduct to find the exact length of the distance. For example, we have this formula for measuring length. The formula is the actual length divided by the measured length equals to length of the used tape divided by length of standard tape.
Okay, so for area we can change the length to area, and also here we can change the formula with the power of 2. For the volume also we can change the length to volume, but normally we will use the length, the first formula, for finding the linear measurements. In this case, for example, we have this case. A measurement has been recorded as 171.278 meters with a 30 meters tape length. So it means this is the measured length, and this is the standard length of the tape. That was only 29.996 meters. So it means the meter or the tape should be 30 meters, but actually it was not 30, it was 29.996. So under standard conditions, what is the correct measurement? So by using this tape that is not exactly 30, we measured this number. So it means this number is not correct. So we have to find it based on a standard tape. A standard tape in this case, in this example, is 30 meters. By using the formula is the actual length. The actual length is not known, we have to find it. Divided by the measured length. The measured length is given, it is this number, equals to the length of the used tape. Okay, the used tape is 29 meters, 29.996, divided by the length of the standard tape. The standard tape in our case is 30 meters. So as you see, only one variable is existed in this formula, so we can find that the actual length is 171.255 meters. So this is the actual length of the line that we had measured. We have a second type of error that we can correct it, that we can conduct corrections by using formulas or by using the mathematical corrections. The second one is the variation due to temperature. As you know, especially in summers, the tape length may change. Okay, they may be lengthened due to the temperature increase. So in this case, we have a formula. CT means the correction due to the temperature, equals to alpha. Alpha is the temperature of or the temperature expansion factor. So normally this number is given and multiplied by L. L is the measured distance, multiplied by delta T. Delta T means the difference between the two temperatures. What are the two temperatures? The first temperature is the standard temperature of the tape. The second temperature is the temperature of the environment that you have used the tape. So we have this simple formula that can be used to find the correction due to the temperature. Normally, if we have a meter like this, under standard temperature, it is normal like this. As you see, this is 1 centimeter, 2 centimeters, 3, 4, 5, 6, like this. But in lower temperatures, okay, in lower temperatures, it means in cold temperatures, as you see, the meter may compress. As a result, the length of the meter will decrease. But in higher temperatures, as you see, especially in the hot temperatures or in summers, as you see, an expansion will happen in the meter. Then the meter will expand and the length will increase. As you see, normally in this case we have to read 5, but in lower temperatures we will read 6 instead of 5, but in higher temperatures we will read 3.5 instead of 5. So it means the true length is 5, not 6 and not 4, or not 3.5. This is for understanding the variation due to the temperature. Now we have this example that has been conducted under the hot temperature that is more than the temperature of the standard tape. You must lay out 2 pointers in the field. Okay, we have 2 pointers. It means we have a line that will be exactly 100 meter. Okay, this is the length of the line. Field's condition indicate that the temperature of the tape is 27. It means this is the temperature of the field. What distance will be laid out? So we have to find the error in the measurement, which the standard temperature for the tape is 20. So the standard temperature is 20. So this means that the temperature should be used in 20 Celsius. But if not, you have to conduct the corrections. This is the formula CT. This is the error due to temperature equals to alpha. Alpha is known. This is this number, as I showed you in this slide. Alpha is fixed, and also L is 100 meters multiplied by the difference in temperature. So the difference in temperature in this case 27 minus 20. This is the temperature of the field, and this is the standard temperature of the tape. Now CT will be equal to 448 meters. So this is the error that has happened due to the temperature change. Now what is the true length of the line? As you see, due to the increase of temperature, the length of the meter has been increased because the temperature is higher than the standard temperature. So it means that the meter has been lengthened. Okay, the length of it is increased. As a result of increasing the length of the meter, you will read a lesser distance. When you will read a lesser distance, you have to add this error to the measured distance. So this is why we can say 100 plus 0.0448 meters. So if the temperature was lower, for example in 5 Celsius degrees, and then you should decrease this number from the 100. But now in this case the temperature is higher, so this means that the length of the meter has been increased. So when the length of the meter has been increased, it means you will read lesser distances. So if you read lesser distances, you have to add this number to the 100. So 100 plus the error, and the true length will be 100 point or 448 meters. We have another variation. We have another type of error due to tension or pulling. Okay, in some cases, if the tape was made of cloth or any other material that could be affected with tension and pulling, so we have this factor to correct the change in the length, because in some cases we may force the tape and the length of the tape will change due to pulling and due to the tension forces. The formula is like this: Cp is the correction due to tension, equals to P minus Ps. P is the applied tension, Ps is the standard tension. Okay, multiplied by L. L is the length of the tape, and divided by A. A is equal to the cross-sectional area of the tape. E is the modulus of elasticity of the tape. So normally this number, those two numbers will be given, and this is the standard P will be given, and also we have to find the PL in the experiments. We have this example. In this example, we have a 30 meters steel tape. This is the length of the tape. Is used with a 100 newtons force. So this is the force that has been applied to the tape. This is 100. It means this is the applied force instead of a standard tension of 50 newtons. So this is the standard tension. This is the standard force. So in the formula, it means we have P and PS. If the cross-sectional area of the tape is 0.02 centimeters square, what is the tension error per tape length, while it is modulus of elasticity is 200 gigapascals. So all the numbers is given. As you see, we have two different forces. Okay, 150, this is P and PS, that's given, multiplied by L. L is the length of the tape. Okay, that is given, 30. A is the cross-sectional area, and also it is given. E is the modulus of elasticity, that is 200. Okay, so why we are multiplying those numbers to 10 with the power of -4, 10 with the power of 9. This is for the equalizing the units, okay, because all the units should be the same. For example, we have the centimeter, we have to change it to meter or millimeter, and also we have to change this, so we have to use the same units. Now CP is equal to 3.75 millimeters, and it is plus. Why? Because we use it a force that is more than this number. We have also another type of error that's called sag. When you are using a tape, you will put a tape in the first point, and also in the second point you will drag the second end of the tape, and in the middle there will be a sag like this. This phenomena is called sag. So the true line of the tape should be like this, this dash line, but normally it will not be like this practically, so it will be sagged like this. This means we will have an error due to the sag condition in the measurements. So we have this formula to find the sag correction. In this formula we have C, that is the sag correction. W is the weight of the tape per unit length, and we have W capital. W capital is the weight of the tape, of the total tape, and we have L capital, that is the length of the tape, and also we have P, the applied tension. In this example, we can find the sag correction. A 30-meter tape weighing 10 newtons is used under a pull of 15 newtons. So which is sagged between two stands. Finds the true distance measure from one tape length. CS is equal to W. W is given, that is the weight of the tape, and also L is given, that is 30 meters. Divided by 24, 24 multiplied by P. P is the applied tension, that is 15. Now finding the product of this calculation, we can find the error due to the sag. That will be equal to 0.55 meters. So now it is minus, because in the formula it is minus. So the true length will be 30 minus 0.55, that will be 29.45 meters. We have another correction that's called slope correction. Slope correction is very easy. Normally we have a triangle like this for the slopes. We have the horizontal distance, we have the vertical distance, and also we have the sloped distance. We have an alpha, that's an angle for finding the other lengths if they have not been specified. So the formula is very simple. We can find h by using this formula, L cosine alpha, and also we can find h by this the other two lengths, the root square of the L square minus D square. So we can find h based on this formulas. We have this example. Find the horizontal distance when a slope rises from one point, a distance of 156.77 meters, to another point at a rate of 1.5. This 1.5 is the slope. So it means in every 100 meters, we will rise 1.5 meters. This is the percent. This means that tan alpha is equal to 1.5 divided by 100. Okay, so by using this formula, we can find alpha. Alpha is the angle. The angle will be equal to this formula, the tan inverse of 1.5 divided by 100, and the result will be this number, 0.85 degrees. Now, if you have the angle, and also if you have the length of the slope, that is 156.77, by knowing the length of the slope and also the angle, you can easily find the horizontal distance. The horizontal distance is equal to the slope distance, or the inclined distance, multiplied by cosine of the angle, and everything is known now. So we can find h that's equal to 156.759 meters. This was about the 5 types of corrections for the linear measurements. Now we have this example. In this example, 2 types of errors has been combined. A 20-meter standard tape was used for measuring a line AB. So we have a line AB, and we used a tape with 20 meters and measured this number, okay, 679.88 meters, while the actual length is 681.24. This is the actual length, this is the measured length, and this is the standard length of the meter. At the temperature of 40, this is the temperature of the environment, use alpha 0.302, and this is the alpha of the tape. So find the used tape length. So we have to find the true length of the tape, because this is the standard length of the tape. The length of the tape should be 20, but the tape that we have used may not be 20. Okay, so we have to find the true length of the tape. At which temperature which the tape be used so that the error approaches to 0. So now we used the tape in this temperature, so we have to find the exact temperature of the tape. Okay, it means the standard temperature of the tape. Now we have this formula for finding because the first requirement is finding the true length of the tape. We have this formula, actual length divided by measured length. This is the length of the line, and equals to the length of the used tape divided by the length of the standard tape. So we have to find the length of the used tape. So everything is known here. The actual length is known, that is this number. The measured length is known, that is this number. And the length of the used tape is not known. We have to find it. The length of the standard tape is 20. Now the length of the used tape is 20.04. So it means the tape that we have used for measuring the length of the line was 20.04. Okay, it was not exactly 20. Okay, this is the first requirement. The second requirement, at which temperature should the tape be used? Okay, so we have to find the standard temperature. Now we have this formula for temperature, Ct equals to alpha multiplied by L delta T. Okay, so the Ct is the error. Okay, already we have found the error. The error was 0.04 because we have the change in the length of the tape with 0.04, because the standard length should be 20, but it was not 20, it is 20.04. So this is the error. CT is equal to 0.04, alpha is given, and also L is given, that's the length of the standard tape, that's 20, T2 minus T, that's the temperature. Okay, so now the temperature has been found, that is equal to 30. What does that mean? It means you have to use the tape in a temperature of 30 Celsius degrees. So if you use the tape in this temperature, so there will be no error with the measurement. We have another question. A survey line measured with a 20 meters chain and 30 meters chain. So we have 2 meters. One of them is 20 meters, the other is 30 meters. Was found to be 998 meters and 1002 meters. When we use this tape, the length was this number, but when we use it 30 tape, the length was 1002 meters. If the 20 meter chain was 0.1 meter short, find the error in the other chain. The other chain is 30 meters. Okay, so we have to find the error in this tape. But how can we find it? First of all, we have to find the true length of the line, because we have the standard length of the tape, that is 30, and we have the measured length of the tape, that is 1002 meters. But this is the formula. By using this formula, as you see, we have the standard length of the tape, okay, that's given, and we have the measured length that is given, but we have two unknowns. So we have to find the true length, the actual length, by using the first tape. Then we can use the actual length for the second tape. Then we can find the length of the used tape, or the error of the second tape. So first of all, we will use this formula for the first tape. So actual length, okay, divide by measured length. Actual length is not known. Measured length 998 equal to length of the used tape. Okay, the standard tape is 20 meters. We are talking about the first meter or the first tape. The first tape is 20 meters standard, but it was 0.1 meter shorter. So you have to say 20 minus 0.1, because the actual length of the used tape is not 20, it is 20 minus 0.1 divided by the length of the standard tape. The standard tape is exactly 20. So actual length will be equal to 993.01. This is the true length of the line in the field. Okay, now we will use this number for the second tape, because the line is the same and the line is not changed, and the true length of that line will not be changed even if you use more than 2 meters, more than 2 tapes. So the line is the same. Now we will find the error in the other measurement. Okay, now we are talking about the second tape. The second tape is 30 meters, and also the measurement by using this tape is 1002. Okay, so 1002 minus the true length, the error in this measurement will be 6.99. Now we can use this formula for the second tape, because we have the true length, or we can say we have the error. You can put the error in this formula, then you will find the error in this tape. The error in this tape will be equal to 0.209 meters. So it means this tape is not exactly 30. Okay, it is it has a deviation of 0.209 meters. So it means we use this formula 2 times. First of all for the first tape, and secondly for the second tape. And the only number that is the same for both tapes is the true length, because the length of the line is the same in both cases. So now we have this example. This is only for homework, so you can use this example for training. Thank you very much. This lecture has been finished, and we have talked about the errors that is important for the practical experiments or for the practical projects, because normally our measurement is not 100% true, so we have to conduct some corrections if possible. Thank you very much.